Right, so I get asked this a lot, okay, because we do these generators and we light something up with it. People say, well, that's great, but how do you actually connect it up? And to be honest, you can just connect it straight. It depends on your load. So if I'm using something like a light bulb or a heater, which just has a resistive load, well, I can connect it straight up. It makes no difference. It'll wobble around a bit, but you can just clip it straight onto the wires. Now, that's often not acceptable for people. They want something that's going to be a bit smoother instead of absolutely up and down. So what you do is you attach a capacitor across the lead. So right there, negative the capacitor to negative and positive the capacitor to the positive. That will smooth the output because the motor will first charge the capacitor. Then when it's running a load, it'll come from the capacitor, not the motor. So if the motor goes up and down, the capacitor will even it out a little bit and make it smoother. Now, the values of the capacitor, obviously, you need to give it a voltage that's coming off of here. So if you're whizzing around and creating like 100 volts and you stick a 50 volt capacitor on, you'll blow your capacitor. So stick a 200 volt capacitor on. So the voltage needs to match what you think you're going to be outputting or what you've seen that you're outputting. Then you need the voltage to match that. The capacitance value itself, well, that's 1000 microfarads, so something around about there is going to be just Jim dandy. Something too small, you won't get much smoothing. Something too large, it'll take too long to actually charge the capacitor. So a nice medium one will do that just Jim dandy, and that will smooth it. Now, sometimes, of course, you want to charge a battery to it, and the problem with this is it is a motor. When we drive it, we're obviously driving the electricity out. If we stop driving it and it's connected to a battery, the battery will treat it like a motor and it'll start spinning. And that's an obvious disadvantage. So to do that, you just connect a diode. So we've got our capacitor across the positive and negative, then our diode on the positive with the anode pointing at the positive and the cathode pointing at the battery. Easy to tell which is which. The cathode's the one with the silver bar against it and the anode is the whole black. So the all black goes towards the motor, silver bar to the battery, and that prevents the electricity coming back. So you'll be charging your battery. When you stop pedaling, cycling, the wind stops, nothing can come back, so it can't run as a motor. Your battery won't discharge. So at its simplest, a capacitor across the wires and a diode on the positive with the anode pointing towards the motor is going to be the answer. It's going to be all you really need. But sometimes, of course, you want a regulated voltage because this is smoothed but not regulated. It's still going to be all over the place. And if the wind is blowing hard, it's going to be high. If the wind is blowing gentle, it's going to be soft. If it gusts, it's going to go up and down. If you're using a hand crank generator, you're going to get tired. So it's going to be all over the place. You might want to regulate that voltage. Now, there are a ton of voltage regulators out there. And I bought this little module, which is the LM259-6. It's a switched voltage regulator. I bought it off of Amazon right here. And as you can see, the regulator itself can take in somewhere between 4 and 40 volts. And you can, this one's a variable one, but you can get them at fixed output of 12 volts. So you would stick a voltage regulator in there as well. This particular board has a couple of other requirements. On the out, you need another capacitor. And on the in, the RMS value is what's really important. But the circuit itself would look like this. The LM259-6 that we can see in there is just something I chose randomly because that's about £1.30 for that entire board. So you wouldn't really bother much with it. It's just pick one that fits your needs and stick it in that position in the circuit and you're away. You'll have yourself a regulated voltage output that you can use to do anything you want. So that's how you go about connecting it up. It's actually really quite simple. Very basically, you don't need to do jack, but you're going to be running a basic load. If you're going to be running it into a battery or something, feedback, stick a diode in there. If you don't want it all over the place, put a capacitor across the two leads, and if you want a regulated voltage, buy a voltage regulation circuit. Now, no motor, no generator is actually DC. They all produce AC. But the commutator and brushes in here rectify it. They rectify it to pseudo DC because it's actually got quite a lot of ripple in it. Because when it rotates, then the commutator swaps the direction and you get peaks. Having lots of coils means you have lots of peaks. You only get the reading at the top of the peaks, but there's still a bit of ripple. So all motors stroke generators generate AC current, but brushed DC motors do a rectification through the brushes in the commutator so that you get a good approximation of DC. Now we can take that ripple out by the capacitor that we put across the two wires that we showed in this video. But of course these aren't the only kind of motors. You get lots of different kinds of motors. You get some motors that don't have brushes, like this for instance, which is a brushless DC motor. Well, this produces is AC. Now there are three separate coils in here, so it has three different wires, and it's busy producing three phases of AC. It's pretty unusual for us to want three phases of AC. We pretty much want one DC output, but it's a piece of cake. You connect a diode bridge over this. The diode bridge is arranged like this, and what that does is convert it into DC. Obviously there's a little bit of ripple in there because of the way you actually run these things, and again you do exactly the same that we did with DC motors. After the diode bridge, connect a capacitor and it will smooth out the ripple. Then again, like we did in the DC motors, connect a voltage regulator and you're there. Another form of brushless motor is the stepper motor. This has two separate coils in it, no brushes, and so of course on those two coils it produces two AC currents. For that, you connect a diode bridge. A diode is just four diodes arranged like this. You connect them up and you get DC out. After the output, connect a capacitor and then your voltage regulator and you're back to the DC brushes. This is quite often used. It's an alternator. This is what's used in your car. This produces AC because although it has brushes, it doesn't have a commutator. The commutator is in segments. In here, to do the collection, there are two solid rings called slip rings. And because they're slip rings, they don't change the direction, and so you get AC out. From an alternator, you actually get a three-phase AC, but inside the alternator is a rectifier. That rectifier means that you get 12 volts out, but it is an alternate current generator that has been rectified in the body using that rectifier circuit that I showed you so that we get DC out. Anyway, I thought I'd quickly run through how to convert AC motors because they're a piece of cake. It's just that with brushes you get rectification, and so you only need smoothing and to prevent the electricity coming back from the battery. With AC generators you need to change it into DC and then the smoothing. Anyway, I hope that helped. Thank you very much for watching, and please remember to like and subscribe.